show you some different apps for the periodic table where you can like click on potassium and it will bring up a bunch of information, including the origin of its name. So I think it's cool. I have one under my pillow every other night. No, I'm just kidding. So the periodic table. The periodic table is pretty important because, as we know, all matter is made up of atoms, and an atom must be a type of element. And so these are the things that make up everything we're familiar with regard to matter. So the periodic table is arranged so that, let's see, the vertical column, okay, this is vertical column, this would be what, horizontal? Okay, so the vertical column, all of these guys have similar chemical properties. And actually, that sort of kind of arrangement, the elements are arranged, first off, according to increasing atomic number, because I think we talked about this before. You know, we have, for instance, lithium is 3, 4, beryllium, and then we go to boron through neon, and then we end with 10, then of course we go down to the next row, potassium, we go that whole row, krypton, and then we go down to the next row. So they're increasing atomic number, but they're also, they wrap around at a critical point. And I think a very good way to show the law of chemical periodicity is the days of the week. So of course, if you have a calendar, you have your calendar maybe starts Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and then we start all over again. Now, if you're like me, you associate certain things on a Friday, for instance, okay? Freedom, Saturday. Sunday, you're like, oh man, my work week's about to ready to start. And of course, we have today as a Monday. So, but then we do it all over again. So what the periodic table does is basically it wraps it around, okay, so that after this day, okay, it's like this day. And so when you're looking at a calendar, okay, all of the Sundays make you think of something. All of the Mondays make you think of something. All of the Fridays make you think of something, okay? And that's kind of the way it is with regard to the periodic table. And if something's periodic, like the days of the week are periodic, we roll around to another week and we begin it all over again. And that's what the elements do. So I'm going to do a little bit with the periodic table. An important thing about the periodic table right off the bat is, I call it the JAG, is this little zippity thing. And that is very important because it separates the metals from the nonmetals. So just looking at this, are more elements metals or nonmetals? More of them are metals, yep. Just a few of them are nonmetals. But if you look at, and on the black and white periodic table, and I mentioned this before, this is actually what you're going to get for your unit exam. So this might be a reason for becoming familiar with it, even though you have one that you got in biology. But this is exactly what you're going to have for all of your unit exams now, okay? So of course you see the JAG. And we have metals and nonmetals. And there are a lot of important compounds formed from these few ones up here. What else we got? Well, along the JAG, along the stair step that separates metals from nonmetals, we have some things called metalloids. And they are highlighted here. There's what, 6 highlighted: boron, silicon, germanium, arsenic, antimony, tellurium, and AT. So they kind of have properties, a little bit of metals and a little bit of nonmetals. So they are kind of neat in that regard. So metalloids are kind of in between. All right, so because of periodicity and the way it's arranged, we basically have a strong relationship of the elements in the same vertical column. The vertical columns are called groups. Sometimes you'll hear me call them families, groups or families. Okay, so they are a family of elements with similar properties, just like your days of the week. So I'm going to kind of highlight that here. Now, as that's kind of scrolling across, can you see where each group or each column, actually there's two designations on this periodic table. And the designation of a column is very important. So that one's 12.2b, that one's 13.3a, 14.4a, 15.5b, etc. On the one that you're going to have for your unit exams, we kind of have a similar thing as to the one being projected. You're going to hear me, in fact, in this lecture, I'm going to kind of focus on the second one here. Okay, that designation. Okay, the other ones may be a little more modern, but I like the whole A's and then B's. Can you see what I mean? We got 2 A columns, and then we have 6 A columns clear over here on the right, and then we have B columns in between. So that's kind of how I focus on them. So along those lines, I want to kind of show you another designation. In addition to metals and non-metals, we can actually take a whole group. So the first 2 groups, or first 2 columns, okay, and the last 6 groups, or the last 6 columns, and those are called the main group elements. And so what letter are they all designated with? Is it A or B? They're all A. Sometimes I'll call them group A elements. Okay, main group elements. Well, the folks in the middle, we have the B elements, group B elements, or transition elements. Sometimes, since these are all metals, sometimes you'll hear them called transition elements or transition metals. Same thing. Okay, they happen to be group B elements. And we're going to talk about these guys down here. Don't worry, we'll get there. Okay, so we have groups going vertically, and then we have periods going horizontally. So that would be like the week, right? Okay. So as that kind of scans down, if you take a look at your black and white periodic table I gave you, over here to the far left are the period numbers. Okay. So they're not showing up. They would be right over here. So for instance, what period, if you find phosphorus, what period is phosphorus in? What do you think? 3. It is. Very good. Phosphorus is in period 3. Let's see. What's the symbol for iodine? Okay. It is I. Yep. Iodine is I. So fine. And it's atomic number 53. What period is iodine in? 5. Exactly. So that's how that works. Are there any questions about that? Okay. All right. So let's talk about these stragglers down here. Now, if you're like, well, these are called the lanthanide series, and they stick in right next to, right after lanthium. Okay? So we have lanthium, atomic number 57. If we go across that period, then we have hafnium number 72. 57, 72, you're like, what the heck? Okay? So actually, these guys down here, cerium through lucerium, I'm not sure. Okay, these guys actually tuck into that gap right there. And when we talk about electrons, we're going to see why those actually kind of are where they are. But those are called the lanthanide series. And notice it says period 6. Do you guys buy that? If you pull up your periodic table, does that seem right? 6, yeah, I'm liking that. Okay, so that's the lanthanide series, and then we have the actinide series similarly. Okay.
So would they be also group 4B?
So what group would they be? I need to double check what that would be. That's a good question. Because the way I think of them is they are kind of actually kind of coming out. If we had another dimension, these guys would come out, and so I think so. I'll double check on what group they could be. definitely would be a B, but then the question is it 3B or 4B? So what's the last period down here? This is period 7, very good. So actually, see this right here? This blank right here? Okay, like where are those elements? Well, actually, as of this summer, and it's been a few years coming, as of this summer, all of these guys are filled out. One of the problems about getting like heavier and heavier elements is, first off, how do they get them? Well, basically they smash two lighter atoms together and make a heavier one and get something heavier. My thing is they create it. So one of the problems I have is they'll say, oh, they discovered this element. No, you didn't discover it. You worked like a banshee to create it, okay? So these are all created. And then after they're created, they have to survive so long. They have to be viable so long. You know, maybe 1 second is long enough, and then they're gone. But they count as an element. One of my things is, how would that be helpful? Okay. But, so scientists are really excited. So what element, should say period, so what period will this one be in? So you guys told me this is 7, so this would be, this new one will be 8. So they're all excited that the next element is going to actually begin period 8. I don't blame them. I think that's pretty exciting. So, all right. So these guys down here, the lanthanide series and the actinide series, collectively they are called the inner transition elements. Makes sense. Because which one are the transition elements?
The B group.
The B group, exactly. So the regular transition ones are these guys, okay, and the inner transition ones are these guys, exactly. While I'm thinking of it, just kind of based upon what I told you about them creating these through 118 protons, 118 is the atomic number of this last guy right here. Anything, let's find, what's the symbol for uranium? What's the symbol? U, exactly. And actually, we'll find in here, it's atomic number 92. Where did you go, uranium? There you are. Okay. So uranium is an important element because it marks the transition between anything like 93 after, this is all man-made stuff. 93 and heavier, it doesn't, its half-life is such that, I guess I would say the age of our solar system is it's not around. Maybe it was earlier, but its half-life, it's decayed since then. So 93 and heavier, you're not finding it. Okay, I just think that is pretty cool too. All right, so it's all about the group, all about the base. JC, don't put your head there. No one go to sleep in here. If you're sleepy, go find a couch. I didn't mean to embarrass you. I should say that to anybody. Okay, good. So there are certain groups that you need to know also. There are actually just 4 groups you need to know the special name for. The first one is the alkali metals. And notice hydrogen. Oh my gosh. Hydrogen is a strange one. Where is hydrogen on the black and white periodic table I gave you? It's 1, yep. But where is it located?
1.
It's located actually twice on the periodic table I gave y'all. Okay, it's here over 1A, and it's also here over 7A. And the reason is hydrogen is kind of a strange sort of cat. It can actually do a couple of things. Sometimes it's similar to these guys, and sometimes it's similar to these guys.
Mine is slightly different than yours.
Yeah.
Is that gonna be an issue?
No, this is actually, some semesters I don't even hand this out, so.
No, these are also different.
Yeah.
Oh, maybe. Yeah, these.
Yeah, so, the thing I gave you, it's no big deal. I just wanted to kind of this semester get the ball rolling, that this is what you're going to have on your test. So those are called the alkali metals. Okay, and here's some pictures of alkali metals. So they tend to be chemically behave similarly, and so one of the things about them is they are very reactive with water. Okay. Okay, then we have the alkaline earth metals, 2A. I have a picture of them. So need to know these names. So on you're going to have some homework that's due on Wednesday that basically kind of has you finding things on the periodic table and kind of talking about these designations. Here's some pictures of them. You will be doing an experiment with magnesium. Magnesium is a 2A element. And then there's two more. Then we skip over, stick with the A's into the 7A, almost off the periodic table. And those are called the halogens. Of course, you've heard of halogen lights. Okay? Halogens are great at being a gas that can be excited in our light bulbs. So here's a picture of chlorine gas. And this is a picture of iodine actually subliming. So iodine is down here. One of the things, sublimation is when something goes from a solid right to a gas. I don't know if you can see that. This is like a hot plate down here. So we're heating it up. It's now iodine gas, and it doesn't liquefy. Usually if you heat up a solid, it liquefies. This skips the liquid stage. It goes right to a gas. And then up here, this is just kind of a cold, probably have ice there in that little round bottom beaker, round bottom flask. And so the ice is allowing the gas to go ahead and crystallize. So that's pretty cool, I think. The last one to know the name for, so there's 4 you need to know the name for, 1A, 2A, 7A, and 8A. So the last guys here, they actually have 3 names by my count, 8A, and they all are kind of descriptive. So noble gases, nobility is kind of like not everybody is nobility. Rare gases, I think that kind of, they both go the same route. These guys are not very abundant. And then they also, another third descriptive name, so I guess you probably need to know all 3 of these names. So rare gases, noble gases, and inert gases. If you get a medicine, and in the medicine they give you the percentage or the inert component, what does that mean? Something's inert in your medicine. It doesn't do anything, yeah. It's filler, it's just a filler, exactly, a binder, you know. So these guys don't do anything. They don't, in that they don't like to react with anything else. And here's some pictures of helium in balloons. Neon is the gas in the sign. Okay. Now if you want to, go ahead where it says 113. You want to update that to 118, you can, like I said, as of June 2016. So these are just some kind of pictures. These are kind of an assortment of elements. One of the things, I have a slide coming up to tell you some general properties of metals. And you having a hard time finding the slide thingy? I guess we're on 7, page 7. Yeah, it does. We skipped all that for now. You're getting close. So one of the things about metals is they're all shiny. Do they look shiny? Yeah, they look shiny compared to non-metals. And then these are a couple of non-metals. So remember, non-metals, are there more or less non-metals than metals?
Or more. Yeah, more. I mean less.
Less, yeah. There's fewer non-metals than there are metals, exactly. And silicon is actually one of those metalloids. According to the JAG, it's on the right side of the JAG, which makes it more of a non-metal if it's going to be one or the other. So we talked about physical and chemical properties. These are all physical properties, things that you can measure without destroying anything. So with regard to metals and nonmetals, we have some distinctions. Metals tend to be conductive, makes sense. They're conductive with regard to electricity and thermal energy. Metals tend to be shiny, lustrous. Metals tend to be malleable and ductile, and they're similar. Basically, a metal you can flatten out into a sheet, that's malleable, and a metal you can draw into a wire, that's ductile. So we'll be talking about this, what you find on a periodic table. Looks like you don't have this slide, I don't think. Yeah, you do, okay. But remember, I already kind of gave you a task that with regard to atomic number, there are certain ones, certain elements you need to recognize the symbol and the name for. And then, yeah. This last thing, I'll go ahead and throw this out because we'll get to this soon. But this last, what I call the decimal number right here, for beryllium, it's 9.01. That is how much an atom of that type of element weighs, but it's a weighted average. So we'll talk about that. That's how much it weighs in AMUs. So we'll take a quick look at these, and then I want to look at periodic tables, periodic table apps. So, yeah, we're clear up to chapter 4. Well, we've been doing this like for 5 weeks now, I think. So you need to find these on a periodic table. These aren't too bad. Find them on a periodic table and say, are they a metal, a non-metal, or are they kind of in between, a metalloid? 56, which are not main group elements. Remember, main group elements are your group A elements. You have 2 columns over here and 6 columns over there. 58, alkaline earth. Which column is that? Which group is that? Alkaline earth? Mm-hmm.
Is that the group, second column?
It is the second column, 2A, very good. So that's 2A. How about alkali metals? It is the first, so that's 1A. Very good. How about halogens? What group is that?
7A.
It is 7A. How about noble gases? 8A. Okay, so it's kind of a scavenger hunt. To which group number? Now, when it says group number, you can go with either designation. I would prefer the A, B, but you can go with either designation. And then last but not least, which element is a row 5? So row, that's a period, right? Period 5, and it is a transition element. What is transition elements? What are transition elements?
Bees.
They are the Bs, yep. I say all Bs, okay, because the lanthanide and actinide series are intertransition elements. Cool. So hold that thought. What I want to do